Now I'm not gonna go into detail about the equations, the torus equations, but I do want to talk about the spheres because we have to understand the sphere, so we have to talk about 3 dimensions, and we've only talked about distance formula in 2 dimensions. So how are we going to calculate the distance? It'll be harder to draw. But a general point, x, y, z in 3 dimensions, how far away that is from the origin. What do you think we're going to have to do here?
Well, we have 3 different ways we could try to think about this. As well, first of all, we're using the Pythagorean theorem again.
Uh-huh.
But we can look at it first. So we want to make triangles. We can look at it first from the distance over x, over y, or over z.
Okay.
So I'm just going to look at it over x.
All right.
So we're going to have a triangle that's...
Be hard to see, but go ahead and draw it.
I'm just going to... So, say this is the x.
Yep.
So, a triangle is our length we want to find.
Yeah.
X over.
Okay.
And up this distance that we don't know.
All right.
But we actually do know that distance because that distance, since it's going to be hard to draw, so I'm just going to draw it over here. Since that distance here is only going over y and up z, we know it is yc square root of y squared plus z squared.
Okay. Good.
So that's that distance. That means our distance we wanted to find originally is square root of this squared plus this squared. Square root of x squared plus y squared plus z squared.
Okay. There you go. So there's our 3-dimensional distance using the Pythagorean theorem. So very similarly, if that's our distance, if I ask you the equation x squared plus y squared plus z squared equals 1, what is this complicated algebraic expression describing?
It's describing a sphere.
Why?
Because it's sort of the same thing. If you take the square root of this, you get a line in 3 dimensions of length 1 that has one end, or line segment, I guess, length 1 centered at the origin.
So we have a center at the origin, a line segment whose length is 1 in 3 dimensions. And this equation has no restrictions on which line segment it's supposed to be. It's just all of them, right?
Yep.
Technically, this is only looking at the endpoints, the coordinates of the endpoints. So this is just like we have the circle.
Sort of a hollow sphere.
Yeah, hollow sphere, just like it was a hollow circle before. And then we can now you can tell me the equation for a 4-dimensional sphere of radius 1. What would that be?
So it's x squared plus y squared plus z squared plus whatever 4th dimensional coordinate.
Right.
I'll say w.
Oh, really? Can you get creative? Fred? Penelope?
I don't know.
X squared plus y squared plus z squared plus Penelope squared equals 1. So that's our standard Pythagorean theorem distance. And for a lot of applications, you'll see, and probably for most of the applications you see, you'll want to be thinking about Pythagorean distance. But as Kelsey Houston Edwards showed us, not all of them.